since I first published it.
No kidding. That is fantastic. I mean, it's also evidence that we love to present on how these missions across the solar system just keep on giving, working with that data that's now, 60 years old? I'm trying to remember.
The data were acquired in 1974, yeah.
Wow. And here's just a shot in the dark. You know that we, the Planetary Society, we help support uncovering the rediscovery of some pioneer data because we had someone at JPL, Slava Turashev, I believe, who was working on the so-called pioneer anomaly, which you know about that.
Yeah.
Could that be some of the same data, or was the data you're working with, was that much better preserved?
That's available from the planetary data system, the data I'm working with, yeah. I think the data that relate to the pioneer anomaly are from the cruise period after the encounters with Jupiter and Saturn.
That's correct, of course, yes. Did Pioneer 10 and 11 simply, whet your and a lot of other people's appetites to go back to Jupiter and orbit?
Absolutely, absolutely. I mean, they were both flybys, so that there was very limited data, but it was rich and allowed us to see that there was a lot more going on than we had ever imagined.
Would you describe it as a fight?
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Gagan.
Hi.
We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves at York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links, or head over to our YouTube channel, YorkU Observatory, to join the chat. We will be monitoring the OPV chat room for questions and showing some archival images from our 1-meter telescope. Unfortunately, no live imaging tonight because it's cloudy in Toronto. For any questions or comments you may have on our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. And as always, you can always connect with us on Twitter or Instagram with the handle @York Observatory, and on Facebook at Alan I. Carswell Obs. So how are you doing tonight, Gagan?
I'm good. Been a busy week, but it's nice to be on the radio after a while. How about you?
Yeah, it's pretty nice. Radio show is always fun. We had an interesting time this week taking apart the 60 centimeter.
Oh, wow.
Someone from, I think it was Arizona, came down to help prepare the 60 centimeter for the new domes and everything.
Okay.
And it was so cool. They took the secondary mirror out. And like actually tested it out when it was outside of the telescope. So I got to see how the mirror moves. And it turns out that the 60 centimeter, like the RA component of it, is actually meant to be it can be moved by hand. So you can literally grab on when the back of it is open, grab like this rail and turn it with your hand.
Oh, wow. Oh my God.
Yeah, it was apparently it was not balanced very well the first time around. So you couldn't do that before, but they rebalanced it. So you can, when the back of it's open, you can literally just grab onto this bar and turn it. And it was so cool.
that it seems so much more convenient than that old panel that we have.
Yeah, it just, well, when we move it now, it doesn't make screeching noises as badly as before.
Oh, that's always a good sign.
Yeah, it's still like, it still makes some bad noises just because it's an old telescope, but you know, that kind of like screeching and crunching that it would make, especially when you started moving it, doesn't do that anymore.
Oh, that was a horrific sound. And then there's like the good creaking and crunching, and then there was like, oh, the bad creaking and crunching.
Yeah.
So that telescope makes lots of noises, but hopefully now it's a little quieter.
Yeah, it is. It sounds a lot better. And it was so cool. All of the panels on the side and everything were off. It was really cool to see inside that thing.
Wow. Man, I wish I'd been there.
Yeah, it was really cool.
Super cool. Yeah, I can imagine. That's awesome.
Yeah. All right, so I think you're first up for our This Week in Space and Astronomy History.
Yeah. So this week in Space and Astronomy History, as we usually kick off, I'll be talking about Comet Hale-Bopp. So as many of our listeners may remember, but neither of us do, on April 1st, 1997, Comet Hale-Bopp made its closest approach to the Sun. And Comet Hale-Bopp, which is also known as the Great Comet of 1997, is a comet that was visible to the naked eye for over 18 months between May of 1996 and December of 1997. And that's the longest any comet has ever been visible to the naked eye. This beat the previous record by over 9 months, and that was the Great Comet of 1811, which was far and away one of the greatest sights that astronomers had seen at the time. And now Comet Hale-Bopp was definitely one for the ages. So comets usually have extremely elliptical orbits, so they're super ovular shaped, and they don't really come around that often. And the closest approach when they do come around, when they're closest to the Sun, is called perihelion, where at this time they're the brightest and also pretty easily observed. Hale-Bopp was one of the brightest comets ever observed, and that perihelion was brighter than every star in the night sky except Sirius, which is the brightest star in the night sky. It actually reached a magnitude of negative 1.8, and observers could clearly see the two tails on the comet. It had a blue gas tail and a grayish dust tail, and these are formed from the ice and rock being expelled from the comet by solar wind as it nears the Sun. Another interesting thing about Hale-Bopp was astronomers noted a third type of tail, a really faint sodium tail being ejected from the comet's core. And this was the first time this had ever been observed. And it could only be observed with really specialized telescopes, but it was a great observation. And the orbital observations for Hale-Bopp actually were matched up with some pretty cool archaeological records. And basically showed that it probably won't come around again for another 4,200 years. And this is a really cool story because 4,200 years ago was around the last time that Hale-Bopp reached perihelion around the Sun. And these orbital calculations were matched up with some ancient hieroglyphics on Egyptian tombs and other carvings, where they described a phenomenon called a long-haired star exactly 4,200 years ago. So the matchup of the orbital calculations and these archaeological records was a pretty great comparison to see when the last time this comet came around. So, I mean, I'm sad I won't be around to see it because I missed the last one by like a year, and now we know it's not coming around again for another 4,000 years. But tell your great grandchildren about this, and maybe they'll keep an eye out.
Oh, that's insane. Magnitude minus 1.8.
Yeah, crazy. And it was, I mean, even NEOWISE was really cool to see in 2020. It wasn't as bright, but it was still bright. You could see it in the evenings. But I can't imagine how bright this was because it was visible with the naked eye anywhere in the northern hemisphere, even in super light polluted, like really downtown core areas. So must have been an awesome sight, and I can't imagine what it would have been like in the rural areas.
I mean, this thing must have been huge too, especially in some of the dark sky sites. Like if you can see it in naked eye in light polluted area, like wow.
Yeah, apparently the two tails were both really visible.
Wow.
And even it was also a really distant comet, so it was huge because it was visible all night, even though it was really close to the sun at perihelion, so it was still visible all throughout the night because it was that far away, even at perihelion.
Wow. Yeah, Neowise was really cool.
Yeah, I remember you got a really great picture of Neowise.
Yeah, I don't know why. I kind of dragged my feet a bit when I came to getting a picture of that. I'm not sure why. I just never got to, it was in the middle of COVID, and I never really got to the park to get a picture of it until it was kind of on its way out. But yeah, that was towards like the end of its visibility, and even like looking at the picture, the tail in that picture of the comet was massive. So yeah, it I think those were relatively short exposures because I don't have tracking on my camera, so it's literally just a camera on a tripod, and you have to do shorter exposures, otherwise you get star trails. But it was pretty short exposures, and you could still see quite a large tail on that. It was fantastic to see. So I can't imagine how great this would have been.
Yeah, I mean, I managed to get likewise on its way out one of the tails on my phone on like a 10-second exposure, but it was really difficult to see. I had to really make some changes to that photo to really make it pop a little bit.
Yeah.
But this must have been, I mean, looking back at the pictures from 97, this was really an amazing sight.
Mm. Yeah. Hopefully, we can still hope that we'll get one of these.
I hope so. I hope we get another, I hope we get something else that we can call a great comet. Mm-hmm. Not just not just a regular comet.
Yeah. We also need Betelgeuse to blow up.
Oh, that's on the bucket list. I mean, maybe not for me, but I'm hoping it happens in my lifetime.
Oh yeah. Yeah, I definitely want to see that. I heard that it's going to be so bright, like you can see it during the day. So there isn't even any restrictions on it has to happen when Orion is in our sky at night. It can just happen anytime.
Yeah, I would. And you know what? Would I travel to the southern hemisphere to see it at night? Maybe.
I think I would.
Yeah, I think that's definitely. Hey, how often is one of the brightest stars in the night sky just going to go supernova on us?
Yeah.
We have to take our opportunities when they come.
Yeah. Speaking of these targeted opportunities, I was looking through some of the JWST approved programs and found a kind of funny name called a disruptive or non-destructive TOO, TOO, target of opportunity. Yeah. It took us a minute to figure out what that was, like reading the name disruptive 2. What are you talking about? But it's a target of opportunity. So they kind of work in if something goes bang or some cool object shows up in the solar system, they can disrupt whatever observation is going on and just immediately point to it.
Oh, so,
yeah. I just thought the name disruptive 2 was pretty funny. Because that's just how it was abbreviated in the type of observation column it was. It's a funny acronym, as astronomers are used to making funny acronyms. So JWST is no exception.
Oh, they love doing that. I can't remember any other ones, but off the top of my head, of course, now that I think about it, I've never heard any acronym ever. But there's always something coming up where they just try to make it. I know some like instruments on Spacecraft, they really do make those as creative as possible.
Mm-hmm. Yeah, some of the proposal names were actually pretty funny too. They had one of them is looking for, I I think it was protoclusters that are obscured by like foreground dust. So the title was "Come out wherever you are."
Oh my gosh.
Referring to looking for these things that were obscured by dust. And then another one was how many dusty galaxies are there over redshifts 3 to 5 really? And the first line of the abstract was, "We will find out."
We will.
Yeah.
That's the energy that we need to take into our research.
Yeah, so someone was being pretty creative with those proposal names and abstracts, which was pretty funny. But we should probably move on to the next item, which also has to do with things going bang, but this time the universe going bang and not a star. And it's the anniversary of when the term Big Bang originated. So as I'm sure most people listening have heard of the Big Bang Theory at some point, either the actual Big Bang Theory or the TV show. But briefly, what the Big Bang Theory is it's currently the best cosmological model for how the universe has formed and evolved. And one of the key predictions of the Big Bang Theory is that the universe had some beginning to it. So all of the matter and energy were compressed into a very, very tiny point. And then at some point that kind of went bang, not really, just started expanding very, very quickly, continued expanding over 13.8 billion years. And when you fast forward to now, we get the universe that we have today after billions of years of expansions. This model was originally formalized by George Lemaitre in 1927, and at the time it wasn't called the Big Bang. It only got that name later in 1949 when astronomer Sir Fred Hoyle unintentionally coined the term Big Bang Theory during a BBC broadcast. Fred Hoyle was an astronomer at Cambridge University who was even knighted for some of his accomplishments during his career, hence why he's called Sir Fred Hoyle. Some of the things that he did was he founded the Institute of Astronomy at Cambridge University. He formulated the theory of stellar nucleosynthesis, which describes how stars create new elements through nuclear fusion in their cores. And he even predicted the existence of an unknown state of the isotope of carbon-12. And that isotope was later found by physicist Willie Fowler, who actually won the Nobel Prize in Physics for that discovery. Notably, but though he did not share that prize with Fred Hoyle. So while Fred Hoyle did a lot of work in his field, he did have a very controversial opinion, which was that the Big Bang Theory was complete nonsense. What he believed was that he believed in this theory called the steady state universe. And he actually founded that theory along with fellow physicists Herman Bondi and Thomas Gold. So what this steady state model of the universe predicts is that our universe is infinitely large and it has existed forever. So it has no beginning. Another prediction of this model is that the density of the universe remains constant with time. The universe can still expand in this steady state universe theory, but as the universe expands, more matter has to get created to keep the density of the universe constant. It's actually a very small amount of matter that has to get created. I remember doing this calculation in my cosmology class last year. I don't remember exactly how much it is, but it's a really, really tiny amount. It's really nothing you'd be able to notice by doing any kinds of observations. But nonetheless, that prediction that more matter has to be created over time as the universe expands is very different to what the Big Bang Theory predicts, which is that the amount of matter in the universe remains constant with time. And as the universe expands, the density of the universe just decreases because you have the same amount of matter and energy. That's not changing, but the volume is getting larger, so the density would decrease. Well, as ironic as this is, even though Fred Hoyle did not like the Big Bang Theory, he was the one responsible for naming it. This happened the first time on March 28th, 1949. He went on a BBC program to discuss his steady state theory of the universe and why the currently unnamed Big Bang Theory was complete and total nonsense. And during this program, in trying to support his steady state theory, he said, the hypothesis that all matter in the universe was created in one Big Bang at a particular time in the remote past was irrational and outside of science. And in the process, he coined the term Big Bang for the very first time. The term didn't catch on immediately. Hoyle went on to do about 5 more broadcasts with the BBC on the topic in 1949 and 1950. All of these interviews were reproduced in BBC's magazine called The Listener, and also made it into a book called The Nature of the Universe. And he used the term Big Bang in all of these interviews. Over time, the Big Bang Theory term started to catch on. It did take a while, though. It only started to appear in papers in the 1960s, and then took a couple more decades to catch on with astronomers. But now it is it's the actual official name for the theory that everyone knows and loves. Hoyle actually denies that he was making a mockery of the Big Bang Theory when he used this term Big Bang, but there are some people that really don't believe him. So there is a bit of debate about whether or not he was just kind of being snarky and sarcastic about, oh, how ridiculous this is. It's some stupid Big Bang that doesn't make sense. But he is adamant that he was not mocking it. He just thought that the term Big Bang was a good way to describe it. But yeah, some people don't believe him. And there is also a little bit of debate about how that might have been one of the reasons that he didn't share the Nobel Prize with Fowler for discovering the isotope, that type of isotope of carbon-12. So yeah, either way, this is the anniversary today, actually, of the term Big Bang.
Wow, I never knew that was such a recent kind of name coining.
Yeah, and I mean, it took a while. So it originated in 1949 and looks like what was it, 20, 30 years to actually catch on among astronomers.
Yeah, and now it's kind of like that's the first thing you learn in astronomy is the Big Bang Theory. It's a household word or name.
Yeah, there's even a TV show named after it.
Yeah, ran for that TV show's probably been running since about the time that it was coined. But yeah, it's been a while.
Yeah, interesting to know. I kind of like to think that he was being snarky about it.
I think so too. There's no way he could bash a theory like this for hours and hours on the BBC and then just say, "Oh, but I was saying it respectfully. I meant it all respectfully."
I always think astronomers being snarky is pretty funny, especially when it comes to their work. I don't know why.
There's a certain level of sass that ends up being present in the astrophysics community, even dating back to the 1600s and stuff, when you used to get into the arguments about the Copernican theory and heliocentrism versus geocentrism. And it was certainly a wild thing to read all their exchanges. Like, I remember Galileo's books and how snarky he would be, and then how he would be punished because of that, unfortunately. But it just kind of amazes me, the for lack of a better word, audacity that everybody has with. I mean, I'm glad they do, because that's how the new discoveries get pushed out.
Yeah. Even now, if you look at some papers, some astronomers will publish direct replies to a paper that they didn't like.
Yeah, it'll be like the theory of the Big Bang, a response.
Yeah.
And wow, the courage to post that in an academic journal. Not post it, but to publish it in an academic journal. Amazing.
Yeah, some of it can be pretty funny. It's not like directly snarky, but it's just sort of like that made me smile a little bit, how you have like scientists arguing with each other, like a reply to whoever at all, and then they reply back to them, and it can get kind of funny.
It's a very polite passive aggressiveness that they share. Yeah,
it's funny. Well, we should probably be again moving on to the next This Week in History item. So over to you.
Thanks. So March 29th, 1974. So tomorrow is the anniversary of the Mariner 10's spacecraft flying by the planet Mercury. So Mariner 10 was a mission in the Mariner series of missions, and it was the first spacecraft to ever fly by and study Mercury, and the mission broke several records. So for starters, it explored two planets, Venus and Mercury, and this was the first time any spacecraft mission had visited 2 planets. It performed the first gravity assist ever to change course and use the gravity from another planet to change its course. It was the first spacecraft ever to revisit an earlier target that it had flown by, which you'll hear about more in a second. So overall, just a lot of really great accomplishments by this one mission, which I was surprised to hear about because I feel like Mariner 10 doesn't get the attention or the recognition it deserves sometimes, having broken all of these records and really setting a precedent for further spaceflight, where we realize with the Voyager missions too that we really can see a bunch of different planets and study a bunch of different objects at once. So Mariner 10 was launched on November 3rd, 1973, and its first encounter was Venus in February 1974. Its goals there were to make atmospheric and surface observations, and it returned a bunch of photos before performing gravity assist to set its course towards Mercury. It reached Mercury for the first time, like I said, on March 29th, 1974, and it returned data on the surface features, which were very moon-like, covered in craters, and it also showed weak magnetic field measurements. It then went around the sun and revisited Mercury for a second time in late 1974 and for a third time in 1975, making it the first spacecraft to revisit a planet that it had already visited. Over the course of its mission, it also imaged Earth and the Moon on its way out and made observations on a comet, C1973 E1. So this was a really productive mission, considered an overall success. It really did set a precedent for a bunch of missions going forward, including other craft that were sent to observe Mercury, and returned a lot of the preliminary data on Venus as well. So it was kind of one of the early markers in missions sent to gather atmospheric and other characteristics of other planets in our solar system.
Yeah, now that you pointed out, I always find that, or at least from what I've seen, missions to like the outer solar system tend to get more, more hype than some of the missions to the inner solar system, apart from Mars.
Yeah.
Yeah.
Basically everything farther.
Yeah. Yeah, but I know there's been some really interesting, or like some amazing missions to Venus and Mercury, like this one, that just from what I see, they don't get that much attention, or they don't get as much as they should, maybe.
Yeah, and it's really these missions that helped us propel space travel and space exploration to those outer planets. And I know Mars gets a lot of attention just because, it's Mars. It's the next big goal on most space administration bucket lists in terms of, okay, we're going to put people on Mars. We're going to do this on Mars. We're going to send a helicopter, which we've done, and a bunch of rovers. So Mars gets that sort of attention, but I feel like Venus and Mercury, they're the forgotten younger siblings of the solar system.
Yeah. Oh my gosh, Mars. Mars is like the center of attention of every like piece of science news for the most part. It gets so much attention.
I was looking at some of the previous show notes from the past few years for this week, and I think 2 years ago, the show was titled, "Is Mars the Best Planet Ever?" And I was like, wow, we're really showing our Mars appreciation here. And deservedly so, but come on, maybe some of the inner planets deserve some love.
Yeah. Let's go back to Mercury, go back to Venus.
Yeah. Venus is probably getting a little more attention now. I feel like people look at Mercury and they're like, okay, it's a bigger moon. What else do we have to see over there?
Yeah. The thing that I always really love about Mercury is that you can use like Newtonian gravity in basically every situation, apart from extreme situations like neutron stars and black holes. And the only other exception to that is Mercury's orbit. you have to use general relativity to work out the details of why Mercury orbits the sun that it does. And it's just this planet in a normal solar system, but the Newtonian limit has its limits in success when it comes to Mercury, which I've always found really interesting.
Mercury is doing special things out there.
Yeah.
We need to pay more attention.
Yes, we do. All right. Well, you mentioned Mars and helicopters, and this is another solar system body that I think a helicopter would be pretty cool if it went to, which is the discovery of Titan, Saturn's largest moon. So while Titan is Saturn's largest moon, it's actually the second largest in the solar system after Jupiter's moon Ganymede. And speaking of Mercury, is also even bigger than the planet Mercury. So this thing is pretty huge. It's March 25th, 1655 is the anniversary of its discovery. It was discovered by Dutch astronomer Christian Huygens using his 5.7 centimeter telescope that he designed and built himself. As with, I think, all telescopes at that point, you kind of had to make your own if you wanted to observe. This was the first moon to be discovered in orbit around Saturn and the sixth moon overall in our solar system. While we now know of the moon as Titan, Huygens had originally just called it Saturn's moon because it was the only moon of Saturn when he discovered it, and he published his results in a paper titled A New Observation of Saturn's Moon. It later got the name Titan a few centuries later when astronomer John Herschel suggested that all of Saturn's moons be named after the brothers and sisters of the Greek god Cronus, which is where they got the name Titan. Ever since its discovery, especially in more recent years, Titan has been the focus of a lot of studies, particularly through the Cassini-Huygens mission. The Cassini mission was a NASA orbiter that was in orbit around Saturn, so studied the Saturn system, its rings, everything. And attached onto Cassini was a European Space Agency probe called the Huygens probe. And in 2005, Huygens detached from Cassini and went and landed on the surface of Titan. This was the very first probe that had ever been sent to land on the surface of a body in the outer solar system. And the Huygens probe, along with the Cassini spacecraft, which remained in orbit around Saturn for many, many years after Huygens touched down on its surface, gave the best and most detailed view of Titan ever, and really revealed the moon to be an incredibly fascinating place. It is the only known moon in our solar system to have a substantial atmosphere, and it's also the only place in our solar system other than the Earth that is known to have lakes and seas on its surface. Also, the fact that it has an atmosphere and liquid on the surface gives rise to weather on the planet, so it has clouds and rains and weather systems just like the Earth does, which is incredibly fascinating since this is a moon in the outer solar system where it's pretty cold. However, unlike the Earth, liquid water cannot be supported on the surface because it's too cold. So the lakes on Titan are made up of methane. There is water on Titan. There is water ice on the surface, and then if you go further down below the surface, there's a massive subsurface ocean of liquid water. So many of these things were discovered and or confirmed because of the Cassini-Huygens mission. Incredibly interesting moon. I'm not sure if there's a mission set to go back to Titan. I know there are a couple missions about exploring the outer solar system moons. I really hope Titan is on the list because this is such a cool planet. It would be cool to send a helicopter to there. If they can have a helicopter working on Mars, I'm sure they can get a helicopter working on Titan because the atmosphere is a lot thicker. So yeah, happy anniversary to the discovery of Titan.
I mean, how is Mercury going to get any attention when you have a bigger moon just sitting out there around Saturn and it has lakes? Yeah, I'm sorry, Mercury. I understand that your whole Newtonian gravity thing is super interesting, but I might be Team Titan here as well because I want to see a helicopter on Titan.
Mm-hmm. I mean, it'd be so cool. The atmosphere on Mars is so thin; it's hard to get a helicopter started on there. But I think it's a pretty thick atmosphere on Titan, and if I'm remembering correctly, because it doesn't have its gravitational field isn't that strong. If you had like wings, you could literally fly on in the atmosphere of Titan. So, I mean, it would, apart from getting it out there to Titan, I feel like it might be a little bit easier to fly a helicopter on Titan than it would be on Mars. So I think it's realistic.
Yeah, I mean, I just looked it up. Its atmosphere is much thicker than Earth's atmosphere.
Mhm.
So if we can get a helicopter flying here with more gravity and less air, I think Titan is doable. The only thing would be, I guess, mission controls and stuff, but we can figure that out. Telemetry.
Yeah. NASA, I think what they could possibly do is do some things like kind of similar to what they're doing with Ingenuity, probably. Or have it transmit, like some lander on the surface transmit to an orbiter, and then that transmits to Earth.
Yeah,
Probably
that
that's
could
what we
work.
do.
I mean, even with the Cassini-Huygens probe, they had Huygens transmitting to Cassini, and there were some transmission problems, I understand, there too, that kind of we lost a lot of the Huygens data during that relay. But if they could get that perfected with a more longer duration of, a longer lasting rover on Titan, I feel like that could be pretty promising. I mean, of course, it's not my billions of dollars that are going to go into this, but I think that's a worthwhile cause.
Yeah, I think it'd be pretty cool. Yeah. Yeah, well, we're about at the half-hour mark now. So for those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. You're listening to Gagan and myself, Sana, currently discussing some astronomy history. Head over to observatory.info.yorku.ca to join the online public viewing chat room to ask us any questions you might have and to see some images taken by our observatory team. You can also connect with us on Twitter or Instagram with the handle @York Observatory and on Facebook at Alan I. Carswell Obs. So we have a couple of interesting news stories coming up, but before that, we do have a couple of reminders. And Gagan, you are first up in the reminders section.
Sure, yeah. So this week, usually every Wednesday, the Alan I. Carswell Observatory runs an online Teletube event, which will usually be a little seminar or presentation about something interesting astronomy related, or maybe even a game show. This Wednesday, though, is an exception. There will be no Teletube this Wednesday. Instead, the Alan I. Carswell Observatory is hosting an event at the York University Arboretum. So the Arboretum hosts a 40-centimeter telescope and a pretty large open-air viewing space. So this event will be open to students, faculty, staff of York University. So you will need a student ID to get in, or any York ID. And sign up is through Eventbrite on the website, observatory.info.yorku.ca. The event will run from 7:30 to 9 p.m. on Wednesday night. And we hope you are able to make it and can maybe get a good night of observing in. In the event of inclement weather, the tour will instead be held at the observatory in the Petrie building on the 3rd floor. So if you are able to make it, rain or shine, there will be a show for you.
Yeah, it's really nice doing these in-person tours again. I went to one, and it's really nice being able to see people in person.
Yeah, I remember the last observatory events we used to do on the Arboretum in 2019, when we were just installing the 1 meter.
Mm-hmm.
Those events were awesome. We had the conjunctions, I believe we had some eclipses up there, and the whole lunar event for the 50th anniversary of the Apollo missions.
Oh, yeah, those were a lot of fun. I remember the one eclipse that was there that happened in the middle of the night. I didn't go to it because I couldn't get home, but it was freezing that night.
Oh, yeah, we did. Sorry, go ahead.
Yeah, it was so cold. I took my telescope out in my backyard for like 10 minutes, close to totality, and got a picture, but it was so cold I didn't focus the camera properly because I just wanted to get back inside. But yeah, that must have been insane on the Arboretum.
Yeah, we spent many a freezing cold night up in that tiny little Arboretum observing office.
Mm-hmm.
Because we used to, for any of you listeners who have not been able to visit the observatory or haven't had the chance to pre-COVID, we used to run in-person observing with the telescopes every Wednesday night, rain or shine, summer or winter. We ran those public observing nights. And so even if it was minus 30 degrees Celsius, we were going to be there at the observatory in the non-heated domes. And we're honestly, the opportunity to use the telescopes that we had at York, it was a pleasure to do it any day.
Mm-hmm. Even when it's freezing and you can't feel your toes.
Yeah, I mean, and then in the event, we'll usually pick up hot cocoa or something from the local Tims.
Yeah. That was a lot of fun, and it's nice that we're starting to be able to do those again. But moving on to the second reminder is that apparently on Wednesday, NASA is going to announce an exciting new observation from the Hubble Space Telescope. They have not been any more specific than that, and I actually can't find too much about this on NASA's website, but the announcement about this was posted on space.com, and they tend to be a pretty reliable source. So it looks like Wednesday we're going to be getting a pretty cool new announcement out of the Hubble Space Telescope. They have not said anything else about it, like not even roughly what field it's in, like galaxies or exoplanets or anything, no idea. But they do note that it's going to be one for the record books. So looking forward to Wednesday at some point to hear about this exciting new observation. If any of you are as excited about it as I am, keep an eye on the news on Wednesday, because apparently there's going to be a great new announcement coming out of Hubble. Pretty exciting.
And they always have to tease us like that. Just an exciting new observation from Hubble. Just give us a hint.
Yeah, I mean, it's piqued my interest. And they were also mentioning something about how it opens up like a new observation opportunity between it and Webb. So, I mean, there's a lot of ways that the two telescopes complement each other. So, doesn't really give much of anything away, but it's very exciting.
For sure. I'm glad to see that Hubble is still up and running, even though the Webb is supposed to be, in all intents and purposes, its successor. I'm glad they'll be working in concert for at least a short period of time.
I'm going to be so sad when Hubble is decommissioned.
Yeah, that's going to be the saddest day since Cassini dove into Saturn.
I know. Yeah, and they've had a couple close calls in like the last year where something like it went into safe mode or some of the instruments stopped working or just something went wonky with the telescope, but they always managed to get it back online. So please just keep it going for as long as you can.
It's the gift that keeps on giving.
Oh yeah, 32-year-old telescope, like it's done a lot. So yeah,
it's older than our 40 centimeter.
Yeah. Hubble is great. But yeah, we should probably get moving on to the news items because we only have like 20 minutes left. So Gagan, you have the first news item about exciting exoplanet discoveries.
Yeah. So just this past week, NASA announced a major milestone in exoplanetary research. And this was the discovery of 5,000 confirmed exoplanets. So exoplanets are planets orbiting stars other than our sun. They've been a really hot subject of study ever since the discovery of the first exoplanet happened in 1992. And this was a planet orbiting the pulsar PSR B1257 plus 12. That's a mouthful, but that's usually how naming conventions in astronomy go. Since that discovery, interest in exoplanets skyrocketed, pun intended, and many research projects have been funded dedicated entirely to exoplanet research, namely the Kepler Space Telescope. So the Kepler Space Telescope ran from 2009 to 2018 for a 9-year mission, and it was dedicated to discovering Earth-size or Earth-like exoplanets around other stars in the Milky Way. And the Kepler Space Telescope was a massive contribution to the search for exoplanets. It discovered in total 2,662 exoplanets, which are over half the confirmed exoplanets ever discovered. Like I said, we're at about, I think, exactly 5,005 right now, and Kepler was 2,662. So really changed the game in terms of exoplanet research. Recent years, even after Kepler's decommission, we've seen a lot of improved exoplanet research strategies, and these strategies have gotten even better, even from ground-based telescopes. So exoplanet research is truly a really, honestly, accessible form of research nowadays. If you're facing a planet's orbital plane edge on, so if a planet or a series of planets is orbiting a star and you're facing the orbital plane edge on, we can do exoplanet research very easily using a small telescope and a transit method, which uses a starlight dimming as the exoplanet passes in front of it. And through this change in magnitude, you can discover several things about the planet, including its size, some orbital characteristics, and if you are able to, spectroscopy can tell us a lot about exoplanets too, and their things such as their composition and other characteristics about it. So I found this really interesting because we actually do exoplanet research at York, and it's a really big part of our undergraduate astronomy research program and in continuing studies and graduate work in astronomy as well. So it's really cool to see the dip in magnitude when the planet passes by. Sun and I, of course, have spent many a long night in the warm room of the observatory imaging stars that have been suspected to host exoplanets and observed some on our own. And all the undergrads at York in the astrophysics program do an exoplanet project for their exoplanets class, where their task is to observe the transit of an exoplanet in front of a star. So each of them will be assigned a star, and they have to come to the observatory and make an observation, and they'll see how the light dips as the exoplanet passes by. So we used to think they were really rare when we first started exoplanet research, we meaning astronomy as a body of science in general. But now astronomers see them popping up everywhere. And when I say everywhere, I really do mean everywhere. We see whole systems just like ours around other planets, and at least about 15% of stars, NASA predicts, host an Earth-sized planet. And many, many more have planets that are smaller or larger that aren't in the habitable zone of that star. So recent estimates show that up to 70% of all stars in the universe may host exoplanets around them. And even the closest star to Earth, Proxima Centauri, which is only 4.2 light years away, has an exoplanet. So what started as a really recent area of study has really blown up to be a massive part of current astronomy research. So really cool to see how far everything's come in only about the last 30 years.
Yeah, a lot of things in astronomy can progress so fast when astronomers have the right equipment. Kepler was an amazing telescope, and there's also a couple, two amazing, more great, that's very, very horrible English, sorry about that. There's a couple more really good exoplanet telescopes coming up. Nancy Grace Roman Space Telescope is going to be great for this stuff in particular.
Yeah, there's exoplanets in general. Just the speed at which this field has picked up is insane. We really didn't know anything about them 30 years ago. I think there were hints of some first exoplanets being observed, but kind of tentatively they were never really confirmed in the mid to late 80s. But late 90s to early 2000s, the field really took off, and I'm excited to see where it'll go next, because there are a lot of reports coming out recently of Earth-sized, Earth-like exoplanets in the habitable zone of stars, which is the zone around a star's planetary disk, basically, that is able to have liquid water present at the surface and it's not too hot. So basically able to sustain human life or life in general, therefore habitable.
Mm-hmm. Yeah, the one of the benefits of the infrared wavelengths that Webb covers is that it's going to be able to detect a lot of the elements like water and stuff like that we have in our atmosphere that's required to support life. They emit a lot at infrared wavelengths. So they'll actually be able to, based off of the light curves of planets in different filters, be able to kind of figure out roughly what the composition of an atmosphere is, which is going to be great for finding possibly habitable planets. So very exciting time coming up with Webb, and in the next few years also with upcoming telescopes.
Definitely.
Yeah, really, really good time to be in exoplanet science too. All right, well, our next news item is a little bit closer to home, which is how NASA has finally opened a 50-year-old sample of rocks from the moon, which was collected during the Apollo era. So during the Apollo missions, which took place in the 60s and the 70s, astronauts returned about 842 pounds of moon samples to the Earth. There were 2,200 different samples in total, which included a bunch of different things like rocks, sand, dust, and some core samples of the moon. Lots of this was analyzed at the time, which led to some very groundbreaking discoveries about the moon, including things like the formation of the moon, its meteor bombardment history, lava flows on the surface, and even evidence of solar activity on the moon. But there was also a large portion of the samples that were not analyzed at the time and were preserved and stored away for future analysis as part of the Apollo Next Generation Sample Analysis Program. The point of this program is basically that scientists at NASA during the Apollo era kind of recognized that while they could do a lot of really good science with the rocks and samples from the moon, scientists in the future in a lot of ways would be better suited or better able to examine some of these samples and could get more out of them than they could at the time. This is just because, instruments and science advances. So they would have more knowledge about the moon, would know for specific things to look for that they at the time that didn't know to look for, and the scientists of the future would have better instruments to be able to analyze stuff that their instruments wouldn't be able to see. So they saved a decent amount of these samples so that scientists in the future could open the samples and get a look at the moon using current equipment and current knowledge. And one of the last preserved samples from the Apollo era was opened last week on March 21st and 22nd. This was a sample taken during the last Apollo mission in 1972, Apollo 17, collected by astronauts Eugene Cernan and Harrison Schmitt. And Harrison Schmitt, by the way, was a geologist. He was the only scientist astronaut to ever walk on the surface of the moon. In the later stages of the Apollo era, they started hiring these scientist astronauts as opposed to simply just pilots, because they wanted to have scientists to be able to go onto the moon and look at things from, I guess, a different kind of perspective than the pilots would have been able to do in the past. But the specific sample that they analyzed here was the lower half of a core sample labeled number 73001. It was collected from the Taurus-Littrow Valley in Mare Serenitatis, which is where Apollo 17 crew landed. The upper half of this core sample, which was named number 73002, has already been opened. It was opened back in 2015. So the sample is now being analyzed in preparation for the upcoming Artemis missions, which are missions that are going to bring humans to the moon for the first time since Apollo. And this includes more diversity in who is going to the moon. There's going to be the first woman, the first person of color, and also people from different countries. So Canada has a couple seats on these Artemis missions. There's a lot of collaboration with the European Space Agency as well. So there'll be a lot more people being able to go to the moon now with these Artemis missions. The first Artemis mission is Artemis 1, which is going to be an uncrewed mission, currently set to launch in May. I believe last week they discussed one of these, a crucial step in the Artemis 1 mission, where they brought the rocket out to the launch pad to do a full-up test of the rocket in preparation for Artemis 1. After Artemis 1, there's going to be the Artemis 2 mission, which is a crewed mission to the moon. Astronauts will not be landing on the moon, they're just going to be in orbit around the moon. And finally, another planned mission is Artemis 3, which will land a crew on the moon for the first time in over 50 years. This is going to happen sometime later this decade, hopefully. There are also some more concrete plans past Artemis 3. There's, I think, plans for missions 4 and 5 and proposed missions up to Artemis 10, which, if happen, will take place sometime in the 2030s at the earliest. So scientists are pulling out this sample now to look at it because they're hoping that studying this sample will yield some kind of important information that will be useful during the Artemis missions. This does include getting some information regarding water on the moon. Lunar water was discovered in 2008 using data from the Chandrayaan-1 mission, and it's likely to be very abundant at the lunar South Pole, which is where Artemis will focus on. So this is a very important thing because water on the moon can be pretty helpful for lunar missions. I believe just to do with things like fuel, you can use water to make some kind of fuel. So it can be a very useful thing for the Artemis missions and for missions further exploring the solar system. So they're just hoping that analyzing this sample from Apollo 17 will help shed some kind of light on just anything useful that they can use for Apollo. And I'm sure we'll be hearing about some discoveries from this sample in the coming weeks to months, because they just cracked this open and are just starting analysis on it this week, really. And of course, this sample will also just be generally useful for any studies of the moon. So pretty exciting, and I'm looking forward to seeing what this sample tells us.
Yeah, that's a great thing that they actually did save up samples from past missions. I feel like a lot of there's a big opportunity to lack that type of foresight where you get those moon rocks back, you get the core samples back, and you're thinking, okay, I'm going to do all my research on these right now. I'm going to use up all my samples. But I'm really glad that they did decide to keep some locked away for future studies because of how fast technology and research capabilities progress. And water on the moon would be a crazy thing, especially just for water reclamation for astronaut use. With Artemis, I think that positioning themselves in a place where water would be accessible at a pretty short notice would be a very good strategic option, regardless of, I'm not sure how the weather at the lunar South Pole is, but maybe it will be a better trade-off.
Yeah, and I mean, it's a really good thing that they did save these samples, because I don't think anyone at the time believed that it would be over 50 years before humans went back to the moon. It's just a ridiculously long time. So if they hadn't saved these samples, I mean, it would have been a lot harder to get them. You'd have to send an uncrewed mission to go and collect samples. And it's always better when you have a human that's actually on the moon and looking at things and going, that would make a good sample, than it is to have a rover or something that picks samples for you. So yeah, really, really good thinking on the part of whoever decided to make this program. Definitely paid off.
Yeah. Also, it's surprising to me as well that there were so many moon missions in such close succession in the 50s, 60s, early 70s. And then they just stopped. I mean, I guess funding for the space programs really fell out once, being first to the moon and being the first to making these discoveries on the moon was kind of over. The novelty of it was gone.
Yeah, I mean, like that's what it was. There were plans, I think, for Apollo up to Apollo 20, but they all got canceled because there was, I think, from what I remember from reading about this, is there was kind of a feeling of like, we did it, we beat the Soviets. There is no point in continuing this, because what if we're spending a ton of money on sending people to the moon, and like with Apollo 13, that was a near disaster. So like, what happens if we send a crew to the moon and they die? Like, that's not good press. So there was a lot of, I think that was kind of mainly one of the drivers for trying to go to the moon in the first place was the Cold War. And then when that was over, it was just kind of like, what are we doing? Which is really
Yeah, it's sad to say that unfortunately that was a major drive for space travel funding during that time period. But I hope that future missions will be going through with more, better research plans, better funding, just for the sake of science and not for, even though, politics will be following everything around, but not purely for the sake of politics. I hope once that these missions start again, I hope they don't stop once we've done it. I hope we keep going and explore bigger and better things.
Yeah, because I know that NASA and I think ESA and the CSA want to kind of establish a more permanent lunar base, so they don't want this just to be like a series of 10 missions and then they stop. They want it to be more like we have I think it's called Lunar Platform Gateway. They want to establish that, and then they want to establish an actual presence on the moon that will be a long-lasting presence apart from just maybe 10 years. So hopefully that sticks.
Yeah, really sort of like ISS type research base.
Yeah, something like that. All right, well, we are top of the hour, so we should be heading out now. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Gagan and myself, Sana. Stay tuned because it's Science Night in Canada. Coming up next is Western World, followed by Quirks and Quarks, and then Science for the People. You can always connect with us on Twitter at the handle @YorkUniverse, and check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.
Good night, everyone.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.